Okay, so the following sheets are a stoichiometry review, and I am not sure that I have the same one here at home or access to the same one here at home that you guys have at the end of your printed packet. There's also an answer key in Canvas that's different than even this one. So let's just go through some of these. The starting material in a chemical reaction, that is going to be a reactant. I'm going to do blue. Ew, I don't like that. Okay, stop. A conversion factor derived from the coefficients of a balanced chemical equation interpreted in terms of moles. That is going to be mole ratio. So, because we get it from the coefficients. Why do I not like any of these? Okay, so that would be G. This one was D. The mass of 1 mole, so it's a mass over 1 mole, is going to be J, molar mass. The maximum amount of a product that could be formed, that's your theoretical yield. We didn't really go through that one. A ratio of 2 equivalent quantities, that would be a conversion factor. And the amount of a substance that contains 6.02 times 10 to the 23rd, that's your mole. The substance completely used up, that's the one that's going to limit it when it runs out or is used up. So it's a limiting reagent, which then let's go to number 9, the substance left over after a reaction takes place. That would be your excess reagent. Number 8, the calculations of quantities in a chemical reaction. Say what? That's just stoichiometry. So we're looking at different quantities. Remember quantitative numbers or the ratios. So that's B. And a stoichiometric computation in which the mass and the mass, so it's gram to gram, that'd be a mass to mass calculation. All right, let's go to the next page here. Up on top on number 2, they're wanting to know the first conversion factor. So if you're going from moles to grams, both are of O2, so it would be moles of O2, line, that goes in the bottom, moles of O2 to grams of O2, okay? So when you see something asking for what's the first conversion to get you started here, that is what that would be. On B, we're going from grams of water to moles of water, so it'll be grams of water in a mole of water. And of course, this is 1 mole, this would be 18.02 when you add up 2 hydrogens and an oxygen. And over here, whenever you're doing grams and moles, top or bottom of each other, you're always adding up the molar masses. So here it's 2 oxygens, so this would be 32. Okay, let's go down and do number 3. Sodium metal reacts with water to produce hydrogen gas and sodium hydroxide. So sodium metal is reacting with water to produce hydrogen gas and sodium hydroxide. Now that sodium hydroxide would be one I'd want to check charges on, but my Na is a +1 and my hydroxide OH is a -1, so I just crisscross 1 to 1 there. Balancing, everything is balanced here, so we're good to go. So your instructions say write and balance the equation. That part's finished. On 3A, how many moles of sodium are needed to produce 7.7 moles? So again, this is a mole to mole, which then we just do the conversion using coefficients. So start with the number they gave you. Line, line, whatever that label was on top goes on the bottom. And then we're going to moles of sodium. It's just a mole to mole. Moles of the thing you underline to moles of the thing you circle. And then we go up and look at coefficients. It's a 1 to 1. So this one would be 7.7 divided by 1 multiplied by 1 is 7.7 moles of sodium. All right, next one. Calcium hydroxide reacts with sulfuric acid in a double replacement reaction. So calcium hydroxide, 2+, and a hydroxide is a -1. So we need to crisscross and bring that 2 down here. Is going to react with sulfuric acid. You can find that in your chem helper. And it's a double replacement. So H and Ca are going to swap. So it will then be calcium sulfate plus 2 minus 2. And H and HO or OH give you water. All right, so let's balance this out. Oh my goodness, this is ugly. Calcium, calcium, SO4, SO4, H2, but I've got that over there. So maybe let's go like this. That gives me 4 hydrogens on each side. And okay, we are ready to go. So this one says how many grams of calcium hydroxide are needed to neutralize this many grams of sulfuric acid. So it's a gram to a gram. So these are the longer ones. This is the second type of problem that we worked on. So you go 28.7 grams of H2SO4, line, line. Here's your molar mass, grams of H2SO4 in 1 mole of H2SO4. I don't have my chem helper or a calculator here. So in the middle, we do the crossover. So this is your mole to mole part. So moles of H2SO4 on the bottom. And we are going to calcium hydroxide. So we put moles of calcium hydroxide. And this is where we just look at the coefficients. It's 1 up here and 1 down here. And I got that from looking at the equation and the coefficients. Then we go to the next one. Again, it's a molar mass, so 1 mole of calcium hydroxide. And then grams of calcium hydroxide would go up here because that's what they're looking for right there. Okay, so you would need to plug in this number and this number, and then you can do the math. The next one on the bottom, how many moles of water from this many grams of calcium hydroxide? So we are using the same equation up top, but here you're starting with grams and you are going to finish with moles. So if you look at the problem above, yes, you're starting with grams and you'll do that again, but then you are going to finish with moles of the part B. So rather than doing this molar mass at the end, you would just finish when you get to that part. So let's take a look at what that looks like. 32.6. So this is one of those mixed problems that page 17 works on. 32.6 grams of calcium hydroxide. Grams goes on the bottom, and then it'll be 1 mole on the top. Anytime you have grams, it goes to 1 mole. Calcium hydroxide. Calcium hydroxide. So you would need to add that up and plug that number in there. And then whatever label's on top goes on the bottom. Moles of calcium hydroxide. And you are going 2 moles of water. And that is what you circled, so that's where you will stop. Now when I look up at that equation back up top, I have 1 mole of calcium hydroxide and I have 2 waters because I look at the coefficients. And then you can do equal there. So 32.6 divided by this number, my gosh, it's got to be like 50, calcium's 40, 58.03-ish, something like that. Divide it by that number, then multiply it by your top, divide by the bottom, and multiply by the top. Okay.